webcast is now starting. All attendees are in listen-only mode.
My name is Muneer Zuhdi. Thank you very much for joining this webinar. This webinar is hosted by the Internet of Things Egypt Forum. I think we can go ahead and get started. So as mentioned, my name is Muneer Zuhdi. I work for Nokia and I will be the presenter in this webinar. The webinar will be end-to-end opportunities in smart cities. We will start the webinar by first examining the smart city opportunity and the key building blocks for an end-to-end smart city solution. Then we will go over some IoT applications in different smart city verticals. The final section will highlight a couple of smart city deployments, and we conclude the webinar with questions and answers. I will be trying to finish the presentation part maybe in 50 to 55 minutes to allow about 5 to 10 minutes to answer your questions. Please feel free to send your questions anytime during the presentation, and I ask you to please your questions so we can answer as many as possible at the end of the presentation. Before we start, just a few words about my background. I have about 20 years of professional telecom experience. I started my career in the United States managing global R&D companies like Dell Labs, Marconi, Ericsson. Then I switched to the operator side and I moved to the Middle East to work for Etisalat, where I did technology strategy, digital and smart city solutions. I joined Nokia about 2 years ago, and I'm currently in the global digital economy practice, heading the IoT smart city solution. I have PhD, Master's in Electrical Engineering and MBA, and I have about 25 American and international patents. Let's start first by examining the smart city opportunity and the different building blocks for an end-to-end solution. The concept of smart city is not new. Some people argue that it goes back as far as 1922 when traffic in the city of Houston in the United States. However, there are some mega trends that are making the smart city concept re-emerge, and they're adding to the urgency of transforming future cities. First, not only we see an increase in the global population, but we also see a rapid increase in urbanization. More people are moving from remote and rural areas into big cities. 2/3 of the Earth's population is expected to live in big cities by 2050, and many megacities are basically the cities with more than 10 million inhabitants. So with this growth, how do we ensure sustainability? How do we ensure public safety for the growing city population? You see different segments of population that we need to pay attention to. Some are aging and needy, others are young and vulnerable. It's also important a social inclusion and address the digital divide in a multicultural urbanized age. When it comes to the environment, the current mode is not sustainable. Cities take only 2% of the total land on Earth, but at the same time, they consume about 70% of the energy and contribute to more than of the pollution. And natural resources like water and oil are becoming more scarce. It's imperative to be very efficient in consuming them. The final form of sustainability is economical sustainability, where cities try to compete to attract large businesses while taking all measures to ensure that young couples stay and work in the city and not move to other cities to pursue better career opportunities. So as the concept of smart city emerged, there has been so many different definitions and bodies. The ITU finally ended up adopting a unified standard definition. They first changed the name to Smart Sustainable City because they believe that sustainability is a critical component of future cities. They defined the Smart Sustainable City as an innovative city that uses information and communication technologies and other means to improve the quality of life for its residents, to improve the efficiency operation and services, and to improve the overall competitiveness of the city while ensuring that it meets the needs of present and future generations with respect to economical, social, and environmental aspects. So the definition envisions that future cities will be able to use technology to address the mentioned challenges and ensure their sustainability. If we examine the different verticals of cities, we find that there are many opportunities to address the many challenges and inefficiencies across the different verticals. If we follow the ITU Smart Sustainable City definition, maybe we use ICT innovations to radically reduce car fatalities, where 90% of the car fatalities and accidents are due to human errors and slow reaction. Maybe we can try to reduce wastage, like in water supply networks. Americans use about 335 billion gallons of water each day. 20% of this amount is actually wasted due to different sources of leakages. So some people estimate that this is actually equivalent to the combined water usage of California, Texas, and Ohio. So this could be all saved IoT sensor networks and monitoring technologies. Also, maybe we can use ICT innovations to try to use to provide assisted living applications to prevent fatalities, if possible. Each year, about 1 million people die worldwide simply by not following doctor's prescription. So the reason for 10% of total hospitalization. So this creates about up to $1 trillion in annual cost globally. So there are so many other numbers to demonstrate existing challenges, but all of them can be opportunities if we use technology such as IoT to eliminate these challenges or to significantly reduce their impact. Thus, people estimate that the economical impact of IoT in cities will be about $1.6 trillion by 2025. So if we look at the different possible applications that address the different challenges of future cities, innovative use cases and applications target to make future cities smart, safe, and sustainable. Smart applications improve people's quality of life, engagement, bolster innovation, and social and economical development, and make cities more attractive places to live, visit, and do business. While safe applications improve the quality of life by preventing or minimizing the risks and impact of adverse events, including crime, accidents, pollution, and natural disasters. Finally, sustainability is also about selecting the right business models to fund, invest, and cost-effectively manage these smart innovations now and over the long run. Examples of include energy management, transport, traffic management, smart parking and lighting, and water and waste management. The was based on the standard layering that you have natural environment elements such as water and air that flow through non-ICT hard infrastructure such as pipes and faucets, which is controlled by ICT-based hard infrastructure, which can be telecom equipment that host the services for the different smart city verticals, or the soft infrastructure on top that facilitate the operation of a smart, sustainable city. This logical flow was mapped by the ITU into an ICT architecture for a smart city. The ITU ICT architecture starts with the sensing layer with all the devices and terminals and their local network. They connect to the network layer, which could be mobile or fixed access network, and the metro network that backhauls the traffic data and support layer, which has the data centers and the application support, and where applications will be served by the application layers. So you finally have operation, management, and security across all these different layers. Now, any smart city solution, if it needs to address the unique requirements for every use case in terms of cost, required power, the throughput, the latency, the scalability, the security, the reliability, you have to do it with the same solution, with the same infrastructure. You cannot have different network for every solution. The solution requirements on the type of the connected object based on the delivered use case. Smart meters, for example, which are used for gas, electricity, will have low mobility and maybe tiny, very, very tiny data requirements, while a connected car or autonomous cars would require high mobility, would require high throughput and low latency. And robotics in manufacturing would require low mobility and extremely low latency. So the challenge is to have a unified infrastructure to cater for all the different requirements of the different IoT smart city verticals. But we also need to make sure that it is scalable, because deployment will start with modest number of devices, which could increase exponentially over time. And the network needs to be able to scale gracefully to accommodate this expected growth. At the same time, the types of services, so the network should have the flexibility and the agility to accommodate different types of services. This should be supported while maintaining a telco-grade reliable security. Since the new target applications will touch on vital, it's very critical to maintain high reliability and high security. Now, speaking of security, we have started to frequently hear reports about IoT service hacking, which is disrupting existing services, like, for example, disabling surveillance cameras, disabling smart meters, traffic lights, or any other services. So sabotage and the disruption of IoT systems aim basically to destroy the system or steal parts of it. A practical example was in South Africa, where SIM cards from traffic lights were stolen in order for people to make some free phone calls with them. Another example comes in terms of manipulating the system. When the criminals gain control of a system, they can manipulate the data that the system generates. So if the system is a sensor, for example, if you have like electricity sensor in the meter or whatever, then the criminal could change the sensor's readings. If the IoT system becomes under control of the criminal, it can then become a bot, part of a botnet that can be used for different types of attacks. The estimated annual the global economy from cybercrime is about $445 billion. And perhaps one important statistic to highlight is also 47% of users who were used in a survey indicated that they would change operator if they experience any security breach. So probably there are two types of impacts here. There's a significant monetary impact, and there's also a non-monetary impact that affects the customer loyalty. Now, if we look at the city solution in a very simplified way, we can put the end-to-end architecture in three different layers. We have the connectivity or infrastructure, we have the platform, and we have to make these layers completely agnostic to each other's. This encourages you to move forward in investing in one layer, such as the IoT, even when you are not sure yet about what application to use, to utilize, and you can build later on like Nokia key competency in delivering standard-based connectivity solution. So the decision to move forward in one layer should have really no implication on what to use for layers. So at the same time, it's important to develop solutions that ensure maximum reusability of invested resources in IoT, rooted in siloed devices, platforms, and applications. And if they are specially built on proprietary protocols, can absolutely stifle innovation. So the effect of this complexity can be felt now, and also in the management cost. It will also show in the complexity and the time to market whenever you need to introduce new applications and new use cases. So our strategy is to always utilize a horizontal platform like the one that we are implementing in our IoT platform, which is branded as Impact, to drive down the cost, mass adoption of IoT applications to scale by applying platform functionality across all verticals without building discrete solution for each application. The approach of Nokia for an end-to-end smart city solution is to match the requirements of smart, safe, and sustainable applications with a shared, secure, and scalable end-to-end solution. So these are we call the 6S here. So we know that the application, these three categories, they can be either smart, safe, or sustainable. So when we look at how to match it with an for the different applications, the solution has to be shared, secure, and scalable. So the Nokia Smart City solution is designed to provide the building blocks for enabling new applications to be rapidly created, deployed, extended, and managed. The building blocks will include the following layers. So starting from the bottom layer contains customer premise equipment, sensors, actuators. So as you know, Nokia is not a major player anymore in consumer electronics, but thanks to our Withings healthcare devices and our IoT-enabled ONT that can be bundled with partner devices, we definitely have something to offer there. And we also have a device certification program that we can do with partners or with devices from third party. Our mobile network portfolio covers the emerging 3GPP cellular radio standards for IoT, such as NB-IoT, LTE-M, extended coverage GSM, as well as LoRa based on unlicensed spectrum connectivity. We also have optimized our mobile core to deal with the specific requirement and behavior of IoT traffic. And there are some applications very low latency. So with these applications, we can utilize Nokia innovations in multi-access edge computing or MEC. Nokia, as I mentioned a little bit earlier, also we have the Impact platform, so we can securely manage any device, the protocols or application. In the application layer, we have a two-sided approach. On one hand, we are building a community ecosystem, but we are also implementing a number of use cases in our respective focus domains. We also have recently added to our end-to-end portfolio the Integrated Operations Center, which I will talk about in a few minutes. So layers, we provide security and services as they have a real end-to-end scope. So our NetGuard portfolio monitor IoT devices, detects them, draws correlation between events in different parts of the network, and set security parameters to minimize the chance of attacks. While our service people have the expertise to design, assess, plan, integrate, and customize any end-to-end solution. Now, the Impact IoT platform can either be hosted or it can be in the cloud. We partner with companies to deliver the connectivity management for SIM-based devices and provisioning. Then we have the device management for managing the entire device life cycle, from auto discovery to registration to provisioning, configuration, the inventory of the devices, any upgrade needed during this life cycle of the device, and any fault management. We also have the data and event collection, which feeds the engine. The platform has an API layer with an extensible object model that allows for flexible devices and use cases to be added to the system without needing any programmatic change to the core product. This enables you to reduce the time and the complexity of the development and for introducing any new applications. The applications themselves can be developed by Nokia, or they can be developed by strategic partners in that area, or we can integrate a third-party application, or basically we can have this open APIs, and an application can be developed by the customers themselves or by academia or by any IoT developers. I mentioned a bit earlier the latest addition to Nokia's end-to-end smart city solution, which is the or IOC. IOC basically addresses the city demand for integrated operation, a unified view for IoT endpoints, whether they are devices or sensors, and also for the application that run along with any alarms that might be generated from these applications. It can run on multi-vendor and multi-technologies and have the ability to customize views of for the infrastructure, for the workflows that you have in there, or the different dashboards that will be needed to monitor the status of the different applications that are deployed. The main benefits from IOC come in improving situational awareness, facilitating better decision-making, improving the response to emergency, and increasing the operational efficiency, the allocation of resources, facilitating cross-agency collaboration. So a lot of different benefits that you can have from having part of the end-to-end solution. Finally, it intends to improve the quality of the delivered service and the management of assets. Now, let's examine some of the smart city use cases and the applications across different verticals. Now, IoT is a very transformative technology with so much potential to transform every industry with a variety of use cases and applications. Therefore, it was important for Nokia to invest in developing an ecosystem, focusing on collaborating and building IoT solutions. The IoT community ecosystem is a subset of the NG Connect program. It was launched during Mobile World Congress in 2016, so just was launched last year. The ecosystem spans a wide range of industries and markets. It includes innovators in all domains. It currently has more than 160 members to collaborate, test, and unleash the business potential of the Internet of Things. The process involves defining solution concepts, collaborating on prototypes, exploring business models, showcasing concepts and feedbacks, and conducting market trials for business model validation. So when we do a trial, it's not just a technology trial, it's also a business model trial, because every application, every use case might have completely different business model requirements. Now, we are initially focusing on a selected number of for which we see clear market drivers and viable business cases. Those verticals are connected public safety, connected digital health, connected mobility, connected utilities, and connected smart cities. Now, due to the time constraints, we will only examine sample use from these verticals. We first start with connected city infrastructure. So city councils are looking for solutions to create smarter, safer, and more sustainable cities. This offers unique opportunities to deploying a horizontal platform that supports applications in different domains like lighting, parking, transportation, environmental monitoring, and safety. So to take one, which is one of the most popular ones for smart parking. So one of the main challenges faced in most cities is traffic. New roads are not possible in established urban centers, in raising public financing due to the disturbances that will be caused on existing dense habitats, and also the expensive real estate, especially when you're talking about big cities. When you go into the city centers, it's extremely hard and changes to expand roads or to add new roads. So, but when it comes to parking, it was estimated that 30% of traffic in city centers is due to people looking for parking. So parking has become a real problem in most metropolitan areas where drivers waste time and fuel while circling to find a parking spot. And they end up increasing road congestions and environmental pollution while risking getting distracted and having accidents. So all these factors lead to huge economical loss for the city. The smart parking solution has a very straightforward process flow. So the customer application installed on their smart devices enable them to get a visibility of available parking spots in the different parking lots at their destination. The app enables the customers to reserve a parking spot, direction on how to reach to that parking spot, and finally make the payment from the app as well. The solution starts with a magnetic sensors to sense the occupancy or the availability of each parking spot. The sensors can either be surface or submount and are expected to have long battery life of possibly up to 10 years. Information from the sensors are collected from a local gateway, and the gateway is managed by the Nokia Impact platform. Impact collects the data and processes it and looks for events and trends which will be reported at the application layer. Two types of applications are supported in this use case, one for the end user and one for the merchant. The merchant app shows real-time data about different parking lots, different parking spots, their availability and all that, their status, and they can also show a dashboard and statistics for basically the behavior for different parking lots in terms of the occupancies, in terms of the revenues that are generated, along with some trend analytics and notifications and alerts. Another interesting use case is video analytics. So we see rising concerns for public safety, with cities around the world to blanket their streets and facilities with video cameras. So although the cameras themselves are inexpensive, but video is very bandwidth hungry service that can congest the network with traffic. So at the same time, the cameras are very static. Identifying anomalies is very manual, and it depends on having an operator monitor an array of screens to identify any suspicious or illegal behavior. The Nokia Video Analytics platform was developed based on innovation from Bell Labs. The idea is to analyze video feeds vectors that represent the density, dwelling, direction, and velocity of the monitored objects. Then by using advanced analytics and machine learning on these vectors, we can detect patterns and identify anomalies. This can be done in real time and at the edge of the network. There are many applications that can benefit from the Nokia Video Analytics platform, mainly to perform traffic and crowd management. Applications range from detecting cars or crowds going the wrong direction or making wrong turns, getting into restricted areas, or if a car is speeding, or if a person is running in a panic in a crowd. You can also detect traffic accidents and how popular are certain billboards or shopping items. The customers that the Nokia Video Analytics solution targets are smart cities who target to perform traffic and crowd management. It could also be advertisers and retail stores who would like to get more insights into the popularity of advertisements on billboards or shopping items in stores. Finally, this use case could also target airports, metro stations, schools, stadiums, and pretty much any area that expects big traffic and would want to detect anomalies in the crowd behavior. We will talk next about a connected bus shelter. So this use case is actually an example for an outcome from our ecosystem. So I mentioned earlier about our NG Connect and IoT community ecosystem. So in this use case, it's all about having a connected bus shelter. Basically, it addressed a challenge and turned it into an opportunity. So we see people spend significant amount of time and they get frustrated during the process, and some might fear for their safety in late hours, especially like if you have elderly people or maybe a woman or whatever, they might not feel safe waiting for buses in late hours. So the idea is to turn the bus shelter into a smart, safe, and sustainable environment, and turn it from being a cost center for the city into actually a revenue generator. So in this application, a broadband connectivity to the bus shelters were provided to enable various networking applications and services, such as interactive digital signage and IP video security. There is also a motion sensor that detects occupancy, and people have the ability to access Wi-Fi and transfer content to their mobile so they can go over their content during their journey. Finally, since occupancy is detected, stops can be optimized to ensure minimum wait time and enhance the overall experience for the passengers. This use case was not just about the technology, as I mentioned before, like whenever we do a trial, it's not just for the technology, but also it was about the business behind it. So when this use case was introduced in New Zealand, a survey was done to check how people would respond to such a new service. So as we can see from the charts, almost everyone found the interactive display to be very useful, and people like being able to browse information and plan for their journey. But the features that people found most desirable were the Wi-Fi access and also being able to feel safe while waiting for the bus. A similar use case here is the connected light post, where we use the real estate that already exists on the post and the availability of electrical power to provide more applications and features that would appeal to residents and visitors. So we can first convert the lights on the post itself into smart lights to control remotely the on-off of the lights, the dimming of the lights to get better visibility of any faulty light bulbs. Also add things like Wi-Fi access points, small cell. We can add an environmental sensor to measure things like temperature, humidity, carbon monoxide, carbon dioxide. We can provide a digital display that show advertisements. It can show also touristic information. It can have news, weather information. It can have safety warnings. Especially, we can correlate it with the weather information if there's any safety alerts that need to be displayed in there. We can also have emergency calling features. We can have connected speakers for public announcements. So there's a lot that you can add on this light post. It depends on the requirements and the things that you feel to residents and tourists. So different areas might have different requirements, and you might have different combination of applications in each area you put this light post. Let's talk next quickly about a connected automotive. There are many possible applications in connected automotive, ranging from fleet management to V2X, which is vehicle to infrastructure communications. So Nokia has been helping customers such as Verizon Telematics, Continental, to secure the remote management of the connected car devices. So with the rise of security breaches, the Impact platform has been used by our customers to provide over-the-air secure software updates. The solution has diagnostic capabilities, which can be used to provide real-time visibility of the city fleet. And then the solution can also be used to track assets such as pallets and boxes to improve the service level and reduce the risk of theft or counterfeiting. So the onboard device dongle in the fleet vehicle is managed, as mentioned, by the Impact platform. It's used to monitor the fleet, to collect and report in real time the location of vehicles. It also reports any alarms or alerts related to battery, related to speed, or any geofencing that can be defined for the vehicle. This also helps provide information about the driver behavior. How is he driving? Is he being very reckless? Does he hit on the brake very hard? Does he speed a lot? So different data points can give an indication about the driving behavior of drivers. So this information is forwarded to the application, and the platform can report in real-time locations and alarms, which can be integrated with Google Maps, with traffic and weather feeds. And the dashboard can also report the statistics for the movement fleet or the assets that are being tracked, along with analysis on trends and behavior. This use case can target different types of customers, such as fleet owners who want to monitor their vehicles and get reports on miles driven, fuel level, and if there's any abnormal usage of brakes. Also to monitor the GPS location of the vehicle, entry or exit into a predefined geofence area. The use case can also target insurance companies who might set their insurance policy based on the usage of the vehicles, and to possibly reward responsible drivers and with discounts, and maybe raise the premium on drivers that being considered to have a high risk according to their driving behavior. Finally, fleet management and asset tracking is also very important for cities wishing to monitor their workforce to get better visibility into the logistics and the supply chain. On the other side, the innovations at Nokia in the area of connected cars continue with the goal of making roads safer for cities. So it's been reported that 50 million people get injured from road accidents every year, and almost 5 million people lose their lives because of accidents. But as I mentioned earlier, 90% of road accidents were found to be related to human errors. So the goal here is to use technology to reduce that risk. So in one of the trials that Nokia did in Germany was for V2X, using Nokia multi-access edge computing technology. So we basically worked on two use cases. One of them is for emergency brake lights to provide for people driving in a lane if somebody hit the brake really hard up front. So at least they get a alert that they have to slow down and they can avoid getting involved in accidents. And the second use case was for cooperative passing assistance, where people get more visibility of their surroundings. So whenever a vehicle tries to change the lane to another lane, they get notification if there's another car approaching very fast on that lane, so everyone can stay in their lane, and we can try to avoid possible accidents. So ideas like that can make roads and cities safer because they alert drivers of hazardous road and traffic conditions when it's hard to see these conditions or when a fast reaction time is required. Now, one cool use case that I would like to show here as an example of identifying an opportunity and putting a solution together to address this opportunity is called connected rental cars. So we see an emergence of the shared economy, where people now are more inclined to rent and only pay for usage instead of owning a car. At the same time, we know that rental cars always try to come up with innovative ideas and all that to customize the rental service to their premium customers to make it as seamless as possible. So what if there's a way for people who want to rent a car to make the arrangement online, get direction for exactly where their car is located, maybe open and operate the car without needing a key, even allow their colleagues to access the car remotely through the app. Maybe they can get complete customization of the car, from their favorite radio stations to the positions of the seat and the mirrors, all according to their preference. And they can also get complete diagnosis, including fuel level, also from the app. So this is what this case provides, basically. It includes the ability to also transfer relevant content from your mobile to the car, to make the travel management for scheduling and for meetings, to get directions, to be able to remotely find and reserve parking spots, and also to pay for parking, to pay for fuel, all this through the car. So finally, since all payments are done through the apps, all associated travel expenses are compiled for business travelers to submit for reimbursement. About their privacy, because any personal data transferred into the car, such as the address book, the call log, the locations that were visited, all will be erased automatically upon returning the car. So again, it's like really putting several use cases together, different technologies, to provide value in a very, very innovative way. Now, the final vertical of use cases that I would like to discuss with you today is the digital home and health. Having a digital home can be an important building block in building a smart city. Home automation and home maintenance make digital homes 40% more energy efficient. At the same time, home security, which is about €34 billion market, makes home much safer. So the Nokia Smart Home solution has basically three key elements. The first element is a single device that acts as an optical networking terminal, or ONT, residential and smart home gateway, and that supports commonly used short-range radios like Wi-Fi, Zigbee, and Z-Wave. The second element is the mobile application, which can be on iOS or on Android, to control the home. This can be used to create rules, to manage devices, and allocate them to rooms. Finally, our Impact IoT platform is controlling the smart home ecosystem with some predefined use cases and management for the smart devices in the home, and to give access to data and statistics via the home app. Health presents a huge opportunity as estimated potential savings in North America alone is $300 billion per year. Nokia's acquisition of Withings enabled the integration of many award-winning health products such as fitness bands, smartwatches, smart scales, blood pressures. So these devices are managed and their data analyzed in the cloud to apply advanced analytics on all vital signs and to provide insights on health and possible risks. So the health data can be reviewed by the users via a patient app, or they can be sent to a healthcare provider. Now, I talked about digital home and I talked about a little bit digital health, but maybe we can combine these two use cases together to address that many cities face now. So this challenge is basically how to care for the elderly population. So people over 65 now are already more than 30% of the total population in so many cities. They represent a significant portion of the healthcare costs, and their safety and well-being is always a concern to their family and doctors, especially if they live alone. So by combining the digital home and digital health applications, we can detect the movement of the elderly and any activities inside the home through the motion and door sensors, and we can check also their vital signs through the health wearables. So by passing the data through advanced analytics engine in the cloud, we can identify patterns and we can detect anomalies. And based on this information, we can either provide information, or if an anomaly is detected, we can send alerts to family members or healthcare providers. Now, we have gone through several use cases and applications covering different verticals, but it doesn't really end there, as there are unlimited possibilities, from the management of drone traffic to building management, from supporting digital signage, augmented and virtual reality, to pollution and leakage detection. But at the end, use cases are usually localized. Every city has a unique DNA. This is why I emphasized early on the importance of having an ecosystem and strategic partnerships, because this is what enables us to identify and respond to opportunities with the most innovative solutions possible. In the last segment of this webinar, we will examine a couple of sample deployments to illustrate different approaches of implementation. The first sample smart city deployment that I would like to mention is Bristol is Open, or BIO. Bristol is Open is a joint venture between the University of Bristol and Bristol City Council. It's funded by the local, national, and European governments with academic research funding, and also by the private sector. It's delivering basically research and development initiatives that contribute to the development of a smart city with IoT. Bristol is Open basically develops an open programmable city. They use small sensors and GPS devices of willing participants to supply the city platform with information about many aspects of the city life, including energy, air quality, and traffic flows. The city operating system will dynamically host these communications and allow the development of a wide range of applications. All the data generated will be anonymized and made public through an open data portal. Nokia was invited to join, where Nokia Bell Labs will provide consulting services to Bristol is Open, while Nokia IP Networking Division will provide SDN network and infrastructure support. The infrastructure will be combined with the Nokia Impact IoT platform, and Nokia's application ecosystem program will bring an extensive range of additional applications, ideas, and companies into the BIO development program. Nokia plans to use this exciting opportunity to test a whole range of applications, from Nokia Bell Labs in video to environmental impact studies, healthcare, and public safety. The first Nokia project in BIO will focus on video analytics on the citywide CCTV system of over 1,700 cameras. The other sample smart city deployment that I would like to mention is in the MEA region in Dubai. So there is one goal behind this initiative, which is basically making Dubai the happiest city on earth. So the Smart Dubai deployment relies on three main technologies. We have the Internet of Things, artificial intelligence, and blockchain. So the journey started in 2014 by benchmarking with global deployment, the ITU, identifying architecture, blueprints, and KPIs. The Dubai Smart Government Office was established along with the Smart Dubai Office, launched a Smart Dubai platform, a happiness meter, a blockchain strategy, and Dubai Pulse, which is basically the overseeing umbrella for all the smart services and applications that are being launched in Dubai. So the Dubai government security networks operator, NIDA, selected Nokia to deliver next generation network for mission critical services with the aim to create safe and smart city for residents and visitors, and to apply the Internet of Things technologies for areas including emergency services, transportation, and healthcare. Dubai also launched an annual award called Drones for Good for the good utilization of drones in future cities. And Nokia won the 2017 award for the initiative of Nokia Saving Lives, where special purpose drones can be utilized by rescue teams to have a portable LTE and highly reliable broadband communications in disaster zones. So as final remarks, I can say that cities are presented with so many challenges that would adversely affect their safety, sustainability, and the quality of life they provide to their residents. It's very critical for city leaders to utilize technology to address these challenges. And by using the Internet of Things, we can find that many of these challenges present opportunities to apply innovative technologies difference in people's lives. Nokia has all the building blocks for a complete end-to-end IoT smart city solution, and our value proposition includes industry-leading infrastructure, end-to-end security, innovative use cases, and strong ecosystem. This has enabled us to win many industry awards. And a lot of these awards were basically given based on the completeness of the solution, based on the innovation in the solution, and also the end-to-end security that is provided in the solution. So the Nokia Smart City end-to-end solution uses the most advanced IoT technologies and innovations to make cities smarter, safer, and more sustainable. That concludes my presentation. Thank you for listening. I'll try to get now into questions. If you have any questions, please go ahead and write it, and we'll go through them. Okay, so I got a question here. How can we begin learning IoT skills to join this tech trip? Very good question, because one thing challenging about IoT is that it is on so many different things. People say that this is really the new evolution of the internet. So the internet started first by connecting content, by connecting people, and now we are connecting things. So there are so many different technologies involved in IoT. So there's the sensor technologies, there's the infrastructure, the telecommunication technologies that are involved in transferring data and all that. And then there's also the cloud technologies, because now to make things cost effective and to expedite the process of adding in new products and new services, it's a lot easier to do all this in the cloud. So what you need to do, what I can tell you, is that you have to really get an overview for the end-to-end solution for all the different technologies in them. You cannot be expert in all of them, so you can try to select which areas really you would like to focus on more. You can look for target applications. So some of the applications that have a huge potential is AR, VR. You have drones also. There's a lot of potential for usage of drones, not only in advanced countries, but everywhere actually. Like even, we see big usage for drones in Africa for delivering medical supplies. Because a lot of times, people live in rural areas or remote areas. They don't have access to hospitals or medical supplies, and the roads might not be best. So they find that it's a lot faster to use drones for the delivery of medical supplies. So a lot of different really technologies involved there, but it's very important to focus a little bit more if you want to really become an expert in one area, to get an overview for the end-to-end solution for all the different building blocks involved in the applications, because this is where you're going to see maybe an explosion in the work. A lot of different companies are trying to identify opportunities and come up with the right application to address those opportunities. And you see a lot of people even dropping out of schools just to start their own companies because they found an application that they like, and they find that there's a big business potential behind it. So you have that, and then on the top of all that, you have the big data, right? So big data, how to process data, how do you make sense out of data? Because a lot of times you have a floodgate, when a floodgate opens and you have a lot of data, it can be overwhelming very easily. So you need to have the right data analytics to drive the right business intelligence and the right business decisions. So now you see new titles emerge as data scientists. So a lot of people now, they have a data scientist title just because there's a big requirement for the analytics of data. Okay, I'll look for other here. What is the difference? Question is not. Okay, let me just see. Also audio. I'm seeing only half of the questions, but I can't see the first half of it. So, what I see here is that, yes, this is all about Nokia solutions. So the question is how generalize this to other solutions and vendors and open source. Okay, so basically what I would assume that the question is that, there's a lot of content in my presentation about the Nokia solution. So how can we generalize it to talk about other solutions and vendors and open source? Actually, if you look at least the first third of my presentation was very general about, smart cities, the drivers, the approaches. So when we talk about, the different applications for smart, safe, sustainable cities, these are all really based on industry publications done by, machine reports by different industry analysts. And then we go into the end-to-end, and given basically the Nokia products was just an example. So the one thing about the Nokia product that I can tell you is that it utilizes industry protocols. So whatever not really proprietary. So whatever you heard from me about the Nokia products could easily apply to some other products as long as they adhere with the support of the industry protocols. And at the same time, in terms of open source, this is really how it should be, especially when it comes to the interface with the application. When I talked about our IoT platform, is that it utilizes open APIs. So the applications themselves can be developed really by anyone. It doesn't have to be from Nokia. It can be from Nokia partners. It can be by a third party, or it can be by university kids or innovation labs. So this is completely open. And this is really where you will see the innovations, really by having this open interfaces. So most of what you heard in this webinar is applicable many other solutions. But I try to highlight some of the uniqueness in the Nokia end-to-end solution as part of the value that I deliver in this presentation. Okay, any other questions? Trying to say here, also audio. Okay. Okay, is there IoT companies here in Egypt, and can IoT be applied here in Egypt? Absolutely. IoT is for really everyone, right? And smart city applications, right? Because the idea challenges, right? To make people happier, to make the environment safer, to make the cities more sustainable. So in Egypt, if you have a need for parking, if you struggle to find parking, then there's definitely a possibility to implement smart parking solutions. If there's any concern about safety, then definitely put video analytics to have a more like a public safety, to ensure public safety. Same thing with, like, preserving water, to prevent water leakage, or to have remote monitoring of utility meters. So there's a lot of different applications that you will find are very applicable to Egypt. But if you want to find what are the most applicable applications in Egypt, you have to think about main challenges that you have. What are the main things that you have that if you apply technologies, you'll be able to resolve these challenges. And relative to the IoT companies, I'm not very familiar with the market in Egypt, but I am sure that there are companies there. I know that there is a big push for incubation. So there are some startups. I was in Egypt a couple of weeks ago, and there was also some talk about about an incubation with the Nile University. So I am sure that there are some companies, not only the big ones, the global ones, the multinational ones, but I'm sure also that there are some small Egyptian startups focusing on IoT in Egypt. Still have a couple of minutes. If you have a question, please go ahead and ask. There's a question: is there any initiatives and use cases or applications in Egypt? What I know, again, I might not be really the best person to only talk about Egypt, because I have limited exposure to the market in Egypt. But what I know is that there's a lot of talk about the new capital. So I'm not sure what initiatives will be targeted there. But this could be, a perfect really area for deploying smart city application and use cases, because it's a green area. So it's always easier to do the infrastructure right the first time when you have a new area that is being built, versus trying to go and implement something on an area that's already built, right? So that's what I can tell you. In terms of case studies, I know that there were some case studies for Egypt. One of them was for the smart utilities, for remote monitoring of smart meters and all that. They looked into the viability and the economics behind it, and they found it to be a very viable business case. So there is some work that is targeting the Egypt market for IoT. Another question: is there a chance for startups in this ecosystem, or customer always prefer big names for such scale? If not, what is the domain available for startups? So what I can tell you, actually, this is a perfect environment for startups, because as I mentioned before, the platform, not only from Nokia, but I'm sure that others will also have open APIs. And this is where you will see the innovations happen. So think about, the App Store from Apple, right? So Apple, they give you nice iPads or iPhones and all that. But if you see all the innovations, it's really happening in developing apps. And the cost of entry became very, very low. So anybody, can develop an app. So you can think almost in similar way for IoTs for smart city. And the best place really for startups is really to look at the use cases and the applications that will ride on top of platforms. But when you go to other areas like platforms, like the network, the infrastructure, especially when you talk about the security requirements and all that, I would expect cities to be more comfortable with established companies. But there's always room for innovations. If you have a great idea, you can try to join one of the ecosystems to try to explore the viability of the idea, not only from a technical point of view, but also from a business point of view. And IoT and smart cities is a huge job. No single company can do everything by themselves. That's why you see a lot of companies partnering. And the partnership is not just restricted to big companies coming together, but it can be really with any that has a viable idea, innovative ideas, can be really a good partner for any bigger companies, so they can go together with the very competitive and innovative end-to-end solution. I think we passed the time. We're already past the hour, so I think this is all the time that we had for this webinar. Thank you very much for joining in. And I think you had my email address. So if any of you had a question that you didn't get the chance to ask, or maybe you sent it and I wasn't able to it, please go ahead and feel free to contact me, and I will be happy to you. This will conclude the webinar. Thank you very much for listening.